Hello, this is Shazil, a final year computer science undergraduate from Pakistan, and in this video we are going to understand about object-oriented design patterns. And the way I'm going to teach you is a bit different. Like, I've been working on this visual content for so long, and this content is curated and designed after a lot of research. So this will make you understand and learn the concept interactively and visually. Okay, so the first design pattern that we are going to study is the strategies design pattern. And to understand this video, you need to have a clear understanding of the basic principle of object-oriented programming, like how classes work, how objects work, and how the encapsulation, inheritance, and polymorphism, lack of concepts, work. So you need to have a clear understanding of object-oriented basics, and then only you can move towards the high level concept of strategy design patterns or some other design patterns that are used in software development. Okay, so from the picture that is in front of you, you can understand that there is a there's a there are three classes, and one is a parent class, and two classes are inheriting from the parent class, that is animal. So this is a simple inheritance concept, and the parent class is the animal class, and two sub animal classes are inherited from the parent class. And you can see that the functionality speak is being inherited in both the animal classes. So the speak behavior or speaking functionality might be public or protected. That's why it is able to inherit in the subclasses or the children classes. Okay, so up till now we have only this scenario. So let's move to the next slide. So in this slide, you can see that there's a person with a yellow cap, and he have some document, and maybe this is a software requirement specification document, and he is reading that. And you can see above that there's written that now the situation arises, and you want to add the fly functionality to the animals. Now something happens, you are developing a game or you are developing some software, and the situation arises that you want to enhance the functionality of the animals, and you want to add the fly functionality to the animals. So how we can solve this problem, and how we can approach this problem? So there are two developers, A and B, thinking about a solution. They are working on a product or a software, and they are thinking about that how we can solve this problem. So there's a developer A who is thinking that we can probably add a new fly behavior to the base animal class. He is suggesting a solution that we can add a fly functionality to the parent animal class. So what would happen if we add a fly functionality to the parent class? So let's say if we add the fly functionality to the dark blue, which is a parent animal class, then both the animal classes are going to have the fly functionality. Simple. He is valid from his point of view, and we can follow this approach. But let's see that what developer B is thinking about. He's saying that good idea, but wait, what if certain animals do not fly? So why they are inheriting the fly behavior or the fly functionality? So developer B is thinking in a bit different manner. Like, he is saying that from the two animals, animal A and animal B, what if in future we have certain animals that do not fly? So they will also going to have the fly functionality unintentionally. Like, we do not want them to have the fly functionality, but if we add the fly functionality or the fly behavior to the parent animal class, then all the children, all the animals that do not even fly are going to have that fly functionality unintentionally. Like, we do not want that, right? So it is not a good solution out there in terms of, or in B's perspective, developer B perspective. So this is not, we haven't find a solution yet. Developer B is having some approach, and developer B is counter questioning the approach that this will be the problem if we follow developers A approach. So let's see that how we are going to solve this problem. Let's move to the next slide. So in this slide, there's a person, and he's saying that we got a solution. Now let's see that what solution he got. So he's saying that interfaces and abstract classes can solve our problem. So if you have studied object-oriented programming, then you might have been through the concept of interfaces and abstract classes. If you have studied object-oriented programming in Java programming language, then there's a interfaces. And if you have studied object-oriented programming in C++, then there are abstract classes. Both the concepts are same, but the terminologies are different in different programming languages. So what abstract classes, the power of abstract classes, that we can provide pure virtual function in terms of C++, and any class that is going to inherit the abstract class would definitely have to provide the implementation for the pure virtual function that are declared in the interface or in the abstract class. Like and he's saying that now any animal that can fly will inherit this interface and implement their fly functionality independently. This is how he solved this problem. He's saying that we will create an interface, this is a fly behavior, and this is an interface or abstract class, and we have this fly method in this, and this is only the we do not have the implementation in this interface. We only have the declaration or the prototype of the function, and any class that is going to inherit this interface would have to provide the implementation in their own way, in their own specific way, in their own algorithmic way. Like how they fly, they are going to write the algorithm specific to them. Like there are three animals, A, B, and C, and they are inheriting the fly interface and in providing the implementation for the fly method prototype or the pure virtual function in their own way. So in this way, how we are solving the problem was that if we would have add the fly functionality to the parent animal class, then the animals that do not fly are going to have the fly functionality. So the animals that only fly, only that animals who are able to fly are going to inherit this interface and provide their fly functionality implementation, and the animals that do not fly are not going to implement the fly functionality or the fly behavior from the abstract class, means they are not inheriting from the fly interface. So this is how we solve our problem, and this is a pretty good problem. This is perfectly solving all the problems. Now there is a person uh, down. He's thinking something. He's saying that it is a pretty good solution, but it is not the best solution. Means he finds some problems in this solution also. Now let's see that why he is saying that it is not the best solution out there. So in this slide, now let's understand that what is written over here. Now as a normal scenario, class A, B, and C class are inheriting the interface and implementing the fly functionality or the fly behavior independently. This is another visual representation of the same scenario, which is explained by classes here. So these classes A, B, and C are inheriting the interface and providing their implementation independently. What if class A and B have the same fly behavior? Why we are repeating the code? So the text that is written in red is very important. Here it is written that if two animals A and B are having the same algorithm to fly, so why we are repeating the code by providing the implementation again and again in their own classes. Like if A and B fly with the same functionality or with the same algorithm, then why they are implementing the algorithm again in their own classes? This is the problem. And in software development practices, we have a principle named DRY, which says that don't repeat yourself. So we have to not repeat ourselves. So here this principle is violated, like the principle of repetition is violated in, and we are avoiding the principle of DRY. So up till now you know that what the problem was and how we approach the solutions, but up till now we haven't find the best solution, right? So let's move to the next slide. So now comes the strategy pattern, what this video is about and what the title of the video is about. Okay, so this person is saying that now comes the strategy pattern and what and how the strategy pattern solves the problem. Instead of implementing the method in the different classes like we were doing in the previous slide, that inheriting the interface, providing the implementation, and it goes. So we are not going to do that right now. So what we have to now create the family of algorithms. But what does it mean? The behavior was to fly and everyone implemented their own fly method. Think with how many different algorithms the animal can fly, called as strategies. Like let's say that there are total 5 algorithms with which the animal can fly. Fly algorithm A, fly algorithm B, fly algorithm C, fly algorithm D, and fly algorithm E. So what we are going to do, we are going to create the interface in the same way, abstract classes or the interface in the same way. We are going to provide the fly prototype in the interface. And but now what we are going to do, we are going to create the classes. We are going to create the classes for the algorithms. This is the fly strategy A, this is algorithm A, this is algorithm B, this is algorithm C, this is algorithm D, this is algorithm E, and now we are going to create the classes. And here it is written that overriding the fly behavior in the abstract classes. Now algorithm A is going to provide the implementation for the fly functionality in its own way. Fly algorithm B is going to provide the functionality of the fly behavior in their own way. In the same way, if we have the in future, if we have any two more algorithms, so what we are going to do, we are going to create two more classes, fly strategy F and fly strategy G. So in this way, that if we have more algorithm in the future, we can cater that particular problem also. So what we are going to do, up till now we haven't talked about that how the animal classes are going to use these algorithms. We have just created the algorithms, and now any animal, let's say animal A, want to use the fly algorithm of strategy D, so he is going to use this algorithm. Let's say animal C and D uses the same algorithm to fly, so they are going to inherit fly strategy B. Let's say they fly with the strategy B, so they are going to, these both animal classes are going to inherit from the, or use the algorithm from fly strategy B. So in this way, that we are avoiding repetition. We are avoiding repetition of code. In the previous slide, what we were doing, we were having a problem like animal B and C. If B and C have the same algorithm to fly, by they are repeating the code in their own classes. So how we have solved this problem, we have just separated the algorithms. And we have defined the algorithm in a different way. We have just keep the algorithms there, and any class that fly with the strategy C is going to use the algorithm or strategy C, and in this way we create the solution, right? So in the next slide, that these are the multiple clients, like these are the multiple animals, for example, or multiple clients that want to use the algorithm. This is a high level overview. So multiple clients defining the type of algorithm they want to use by setting their desired pointer on runtime polymorphism. So if you have ever understand or deeply understand the concept of polymorphism, that there's a concept that if we create any class pointer, like we have a parent class and there are 5 children of that parent class, and if we create a pointer of that parent class type, then we can assign an object of any child classes to that parent class, and this is a polymorphism, right? Like the parent class is going to adopt the form of any child class at runtime, and this is adopting to the behavior of multiple forms. This is just defining the concept of multiple forms. So we are going to create the pointer of this type, fly behavior type, and if animal A want to use the algorithm E or fly strategy E, so animal A is going to pass the object of fly strategy E to this class, and it is going to set the pointer of this class, and now animal A is going to is able to use the algorithm or the strategy E. So in this way we are doing this. So here it is written that a pointer of base class interface, the actual type of the object pointed to by this pointer can be any class algorithm derived from the strategy interface. So this, if you haven't understand polymorphism, then you should first understand polymorphism, then this slide will be clearly understandable to you. Decided by the client which to use, like there are 5 animals or there are 5 clients, and client A wants to use algorithm C. So what he's going to do, he is going to provide the object type of algorithm C or any algorithm he wants to use to the base pointer that is declared in the interface. So in this way, the strategy pattern lets the algorithm vary independently from the client that use it by using the polymorphism. Okay, so this is all about strategy design pattern.